All right, welcome back to the deep dive. So today we're going to be drilling down into a really specific piece of 1U rack gear. It's the Blustream PWR8VDC8 port-managed low-voltage PDU. And our mission really is to figure out what makes this thing tick, what turns it from just a fancy power strip into, well, into a smart command center.
Exactly. And it's important to set the scene, I think.
Right.
For you listening, this is not for, massive server farms.
No, definitely not.
It's an outlet-level, metered and switched unit. It's built for very controlled power delivery to low-power devices. So think AV installs, maybe some edge computing. It takes standard AC power, 110 up to 250 volts, but the whole thing is capped at 10 amps. It's all about precision.
Okay, so let's unpack the physical design here, because it's pretty unusual. You've got a standard C14 power inlet, which is normal, but the outputs are where things get really different. 8 outlets, but they're these configurable 2-pin Phoenix connectors. Let's stop there. Configurable how?
Yeah, that's really the headline feature, the flexibility. Each one of those 8 outlets, you can individually select the voltage.
Oh, individually.
Individually. You can pick 5V, 9V, 12V, 18V, or 24V DC.
Right.
And each outlet can handle up to 30 watts.
I see.
So what that means practically is you are just eliminating that huge mess of wall warts and power bricks. You standardize the power right from the rack. It makes cabling and maintenance so much simpler.
That makes a ton of sense. But it's not just the Phoenix ports, is it? I saw it also has managed USB-A ports, which seems like a very clever addition.
It's super clever.
Yeah.
8 managed USB-A ports, perfect for powering other little third-party devices in the rack. But you do have to watch the current limits. It's important. Ports 1 to 4 give you 5V at 1 amp.
Okay.
But then ports 5 through 8, they're limited to 500 milliamps. So there's some precise power budgeting you can do there. And of course, it has the safeguards you'd expect. Overload protection, interference filtering. Reliability is everything in these kinds of setups.
So that's the hardware. Let's talk about the smart layer. The brain of the operation, really. It gives you all this monitoring, data, voltage, current, power, energy consumption. But why is that so important? I mean, beyond just, seeing how much juice you're using.
Well, it's about predicting failure.
Yes.
It's proactive management. That granular metering lets you see a spike in consumption. Maybe you have a device that's about to fail.
Ah, so you can catch it before it dies.
You can catch it before it takes the whole system down with it. Plus, it allows for things like scheduling and power sequencing. You can reboot a stuck device remotely without ever touching it.
And the connectivity is what makes all of that possible. What's the infrastructure look like for that?
This is where it gets really fascinating because of the redundancy. It has dual TCP/IP network ports.
Dual ports, okay.
So you always have access. You
Yeah.
always have control. It's all secured with SSL, naturally. But they also included legacy control. So you've got RS-232.
And just still huge in the AV world.
Still vital, for gear that doesn't speak IP. And it has relays for the actual physical switching. You manage all this through a secure web GUI.
So connecting that network intelligence to the physical world, that's where the integration potential really shines, right? We mentioned the relays for automated switching, but I noticed there are also manual buttons on the front panel. A proper fail-safe.
Exactly. And that kind of begs the question, what can this PDU actually react to? And that's where the 2 multi-format sensor ports come into play.
Okay, so what plugs into those?
Well, third-party environmental sensors, things that measure temperature, humidity, air pressure, even security sensors like a door contact. This data can then feed into a larger building management system, a BMS, and the PDU can react automatically. For instance, if the temp in the rack gets too high, it could trigger a sequence to shut down non-critical devices to prevent damage. And, it's a standard 1U design, easy to mount, and it comes with a 5-year warranty, which tells you this is meant to be mission-critical gear.
So if we pull it all together for these low voltage or edge setups, what's the big takeaway? It sounds like it's about granular control, very precise voltage, and deep monitoring, all with some serious network redundancy built right in. You're not just powering things, you're managing their health.
You are. So here's the thought I want to leave you with. If controlling voltage and current so precisely gives you these huge benefits in stability, how far could we push that? How much could automating based on environmental factors, temperature, humidity, air pressure through those sensor ports, how much could that revolutionize the reliability of a small, critical installation that doesn't have its own dedicated cooling or monitoring? That, I think, is the real power this unlocks.